So first word is going to be cell membrane. Cell membrane is the outer part. It's towards the outer part. It's the barrier between the cell and the outside world. It determines what goes in and out of the cell. It's made of proteins, cholesterol, phospholipids, carbohydrates. It has all those in there. Again, cell membrane separates the cell from the outside world. It's semi-permeable. Determine what goes in and out of the cell. Made of phospholipids, proteins, carbohydrates, cholesterol. Cell membrane. Alright, so next word I want to go into is the lipid bilayer. And if you see behind me, you can see the lipid bilayer. Notice these are phospholipids. All these the little balls are the heads, and the little legs here, they're called the tails. Okay, so like this is a nice big example of it, like zoomed in. Okay, you got a phosphate head and lipid tails. Okay, and it's called phospholipids. So lipid bilayer is so write this down, 2-layer, double layered of phospholipids that make the cell membrane. A double layer of phospholipids that make the cell membrane. That's why it's called a lipid bilayer. Next word, hydrophobic. Hydrophobic. What is hydrophobic? Hydrophobic means afraid, like a phobia, like you're afraid of something. So hydrophobic would be afraid of water. So hydro would be water, phobic would be afraid. So hydrophobic, think of it as afraid of water. Okay, or you could say not attracted to water. All right, now what is hydrophobic on a phospholipid? Here's a picture here of a phospholipid. All right, phosphate in the top, the lipid tails right here. Okay, the lipid tails are the hydrophobic part of the phospholipid, the lipid tails. That's why if you look at a cell membrane, they're going to be to the inside because they don't want to touch the water. All right. Now, hydrophilic. Now, think of that. Hydrophilic, like water loving, but likes water. Likes water. All right. Wants to lick it, like you lick a lollipop. You like a lollipop, you lick a lollipop. You like your ice cream, you lick your ice cream. So hydrophilic, think of it like it likes it, it wants to lick it. All right. Like a phosphate, the phosphate heads here, they are hydrophilic. All right, and that's why they're going to be towards the outside of that cell membrane. Why? Because they want to touch water. Okay, they're going to be wanting to touch water. So they're going to be hydrophilic. Okay, they like it, they want to lick it. All right, so now we're looking at a semi-permeable. What is semi-permeable? That means some things go through, not everything. It's like with imagine a fence. A fence, some things go through the fence, not everything. Does air go through a fence? Yes. Can water go through a fence? Yeah. If you spray your water from your hose outside, won't that go through the fence? Yeah. So some things can go through, not everything. If you try to throw a basketball through a fence, it's not going through. Okay, so again, semi-permeable. Some things go through, not everything. Like a fence or a tea bag. You know, if you've ever seen a tea bag, it has little tea leaves inside of it, and you put it in the teacup with the water, and then what happens? Well, stuff comes out of it, but do all the tea leaves go inside the water? No. So some things go through, not everything. Semi-permeable. Some things can go through, not everything. If it's small enough, it'll go through. Like I said with the fence, air molecules are small enough, so they'll go through the fence. Water molecules small enough, so it'll go through a fence. A basketball is not going to go through a fence. All right. So again, semi-permeable. Some things go through, not everything. Semi means kind of. Okay. So semi. Some things go through, not everything. Semi-permeable. This word is very important. This word is diffusion. All right. So the word that I'm going to go over right now, super important. It's diffusion. All right. And that's when molecules go from high concentration to low concentration. That is called diffusion. If I was to pass gas right now, okay, the gas that's in my pants would be doing diffusion. It would start off in my pants and it would go throughout the whole classroom. People would smell it, you know, as it's diffusing through the class. Okay, so diffusion is from when you go from high concentration to low concentration. The movement of molecules from high concentration to low concentration. If I pass gas, do you think all those stinky molecules are just going to stay in my pants? No, what are they going to do? They're going to diffuse. They're going to spread out, all right, throughout the class. So think of diffusion kind of like a spreading out of the molecules. If you look at this picture here, it shows you, right there, it shows you where do you see more molecules? Well, I see more up top. Where do you see less? Oh, at the bottom. So what does that mean? It's going to go from the top to the bottom. Why? Because from high concentration of molecules to lower concentration of molecules. That's how naturally things go. All right. Again, if I pass gas, what's naturally going to happen? It's going to diffuse throughout the classroom. All right. Now, you could say the same thing with perfume. If I was to squirt or what do they call it? Air freshener. If I was to spray some air freshener and I spray here, it's going to do what? It's going to start here, but the smell is going to do what? Go across throughout the whole room. Okay? Because the molecules go from where there's more molecules and they'll spread out to where there's less. And that is called diffusion. So now, facilitated diffusion. Facilitated diffusion, that's going to have a little bit of help. All right? So if you look at the picture there next to me, you will see facilitated diffusion happening. So remember, diffusion is when you go from more molecules to where there's less molecules, from high concentration to low concentration. So if you notice, facilitated diffusion would be like that, but instead you're using a protein channel like you see, and we talked about already. So you're using a protein channel to facilitate. Facilitate means to help. So the word facilitated means helped. So you're using a protein channel to help the molecules go across from high concentration to low concentration. Make sure you write this down. No energy needed. No energy needed. So again, facilitated diffusion. No energy needed. Use a protein channel. Facilitated diffusion. Use a protein channel. No energy needed. That's facilitated diffusion. All right, so the next word is protein channel. If you notice, that's a protein channel right there. It goes all the way through. All right, it's like a channel. It's like an opening all the way through there. Okay, think of it like a canal, or canal lets water go through, but it's a channel. So a protein channel. It's used. So put this down for protein channel. Used during facilitated diffusion to allow molecules to go through easier. Think of a protein channel like, again, if we were talking about that fence for semi-permeable, remember that? So a protein channel would be like if I cut a hole in the fence. If I was trying to throw a basketball through the fence, well, the basketball couldn't go through. But now if I have a hole right there, now the basketball could go through. So it allows easier for it to transport through easier. All right. Same thing if I was trying to squirt water from a hose onto the fence, and now I cut a hole in the fence, I can make more water go through that hole much easier than if it had to hit some of the fence and then go through. All right. So facilitated diffusion happens because of the protein channels. Okay. Think of it like it's like a tunnel. Okay. Think of a protein channel like a tunnel. And that tunnel goes through the cell membrane, and it allows things to go through the cell, into the cell, and through the cell much easier through facilitated diffusion. All right, so protein channel, think of it like a channel, like a tunnel that goes through the cell membrane to allow facilitated diffusion to happen. All right. Next word is active transport. Active means you are using energy. So active transport, put transporting using energy, and then next to the energy you put slash ATP, because when you're talking about energy and living things, you're talking about ATP. You see it going on right here. See ATP? Once you see that word ATP and it shows you a protein and it's showing you the ATP right there, you know right away that must be active transport. All right, ATP, and it's moving it. Once you see that ATP in that picture, you know it's active. Why? Because ATP is energy and active needs energy. So again, active transport, just put uses energy, using energy slash ATP to transport, and then also put down moves against concentration gradient low to high. Moves against the concentration gradient low to high. All right, so it's doing the opposite of what naturally would happen. You're forcing it to happen. Okay, how do you force it to happen? By using ATP. All right, it's like a vacuum cleaner forcing air in. Okay, how does a vacuum cleaner force air into it? Well, it uses energy. Usually we use it from the electrical energy, right? So again, active transport, transporting molecules against a concentration gradient using energy slash ATP, because ATP is energy, to make it happen. So if you see that, you see a picture of ATP, it shows ATP and it shows you the molecules moving across, you know that's active transport. All right, so now we are on passive transport. Passive transport. Now with passive transport, what's happening is you are not using energy. Okay, passive, you are not using energy. Okay, you don't need energy for passive. It's like you're just sitting there, right? You're being passive, right? So you're not using energy, okay, to move molecules. Goes with concentration gradient. Goes with the concentration gradient. High to low. Goes with the concentration gradient. High to low. And then again, passive, no energy needed. No energy needed. Okay?